Welcome to this in-depth exam prep explainer on NCSP-MCI 7.5 to 11.5 Practical PC Protection Guidance. Look, if you're an infrastructure admin gearing up for test day, you've landed in exactly the right spot. We're going strictly by the book today, focusing on the baseline AOS 7.5, AHV 11.0, and PC.7.5 requirements. Our goal? To build a rock-solid understanding of management plane resiliency. We're going to cover everything you absolutely need to know to ensure your multi-cluster management is basically bulletproof. And honestly, more importantly for you right now, we're going to talk about exactly how to tackle those highly specific scenario questions you're bound to see on the exam.
Okay, let's take a quick look at our roadmap for today. We're covering 1. Why PC protection matters. 2. A walkthrough of scale-out HA. 3. A walkthrough of the PCBR backup strategy. 4. Common exam traps. And finally, 5. Key facts to memorize. Let's get right into it.
Section 1. Why PC protection matters. We're going to start by establishing the stakes here.
Before we get too deep into the weeds, let's quickly lock in our terms. I know, as infrastructure admins who probably live and breathe this stuff every single day, but it's crucial we're on the same page for the exam. PC stands for Prism Central, that's your multi-cluster management plane. And PCVM is the Prism Central virtual machine, which is the actual guest VM or VMs hosting that instance. So why does protecting this matter so much? Well, think about it. If your PCVM goes down, you don't just lose some dashboard visibility. You immediately lose access to your centralized automation. Imagine hitting an outage and suddenly you can't touch your centralized playbooks, your Calm blueprints, or your Flow microsegmentation policies. You're basically flying blind, with zero control over your entire Nutanix environment. That real-world operational paralysis? Yeah, that's exactly why Nutanix engineered very specific required handling for these virtual machines.
Moving on to Section 2, Walkthrough of Scale-Out HA. Let's look at how we survive unexpected node failures. High availability, or HA, is a total game changer here. When we talk about HA for Prism Central, we mean actively scaling out from a standard single VM deployment to a robust 3 VM deployment. And this isn't just for show. This architecture is designed to provide seamless fault tolerance and load balancing right out of the box. What you really need to understand for the test is that this load balancing operates completely in the background. Once you set it up, there's absolutely no manual intervention required from you to route traffic if something breaks. The overarching goal is super simple. If a hardware failure hits one of your hosts, your management plane does not go offline, not even for a minute.
Now, think about the huge contrast here. With a single VM PC, if the underlying host fails and you aren't using other hypervisor-level protections, your Prism Central instance is just gone, completely down until that VM can reboot on a healthy host. But with a scale-out 3 VM setup, you've got that active load balancing we just talked about. If one PCVM fails, the other two instantly take over. It's seamless. However, and this is a massive point for the exam, there is a strict limitation. A 3 VM setup only survives the failure of exactly one PCVM. If 2 nodes crash at the exact same time, the entire Prism Central instance is considered inactive. Keep that front and center on test day. One failure only.
You also absolutely have to know the baseline requirements that actually make this HA architecture possible. You can't just click a button and hope for the best. Your infrastructure has to meet these firm minimums. First up, the PCVM itself has to be running version PC.2024.1 or later. Second, the underlying cluster, your Prism element, has to be on AOS 6.8 or later. And finally, if you're running AHV, it must be version 2023-03-02-10173 or later. If you get one of those tricky scenario-based questions asking why HA isn't available for a specific deployment, check these version numbers immediately.
Section 3. Walkthrough of our PCBR backup strategy. We're shifting gears from running resiliency to full disaster recovery.
So even with HA enabled, you still need a safety net, right? If the unthinkable happens to your primary data center, you need a way to restore. Enter PCBR, or Prism Central Backup and Restore. This is Nutanix's automated, purpose-built solution just for protecting Prism Central. The crucial thing to grasp here, and I can't stress this enough, is that PCBR is not just doing some simple, flat disk copy. It perfectly captures the incredibly complex configuration state of the management plane. We're talking registered cluster details, intricate role-based access control roles, customized security categories, the whole shebang. Capturing this specific state is absolutely critical because it ensures that when you hit restore, you don't accidentally break the communication links to your registered clusters. Under that PCBR umbrella, continuous backup is your bread and butter. It maintains this real-time safety net, constantly backing up that complex configuration data. But where does the data actually go? It gets backed up to 3 registered AHV or ESXi clusters. Notice that cross-hypervisor detail. That's important. It ensures that even if the cluster hosting Prism Central goes completely dark, your configuration state is safely tucked away on your other managed clusters, just waiting for a rapid recovery. It's a really brilliant self-contained strategy.
All right, before we memorize the specific performance metrics for PCBR, we need to be crystal clear on what RPO and RTO actually mean in the real world. These terms get tested heavily. Recovery Point Objective, or RPO, is your maximum acceptable data loss time. Basically, how far back in time does your backup put you when you finally hit restore? Recovery Time Objective, RTO, is your maximum acceptable downtime. How long does it actually take to get the system fully restored, booted up, and actively managing your clusters again?
Section 4. Common exam traps. Pay super close attention to this part because we're going to expose the exact tricks they use on the exam. Let's start with a direct quote straight out of Knowledge Base Article 9850. The only supported method for backing up a Prism Central VM is to use Prism Central Backup and Recovery. Period. Full stop. This is the golden rule. You must absolutely, without exception, exclude your PCVMs from any standard VM-level backup jobs. If a question asks how to back up a PCVM and PCBR is on the list, that is your answer. Just ignore the other tools.
You know how exam writers love to test if you know what not to do, right? Well, they're going to throw some highly dangerous distractors at you. You'll likely see options like protection domain-based DR, protection policy-based workflows, third-party backup software, or even async DR snapshots presented as totally valid ways to back up Prism Central. Identify them immediately as traps. I know it's super tempting for an admin to just throw the PCVM into a standard async DR schedule because it feels familiar. But if you try to use any of these standard methods, you will ultimately render your Prism Central instances completely unrecoverable. So, why is this the golden rule? The why here is actually really fascinating. Taking a traditional legacy snapshot of a PCVM via some third-party tool totally fails to maintain that intricate state information we talked about earlier. If you try to restore from one of those legacy snapshots, you cause fatal state inconsistencies between Prism Central and the individual Prism elements. And the real-world symptoms? Oh, they're bad. You'll get random service crashes, your PCVMs will just randomly reboot, and you'll experience a total loss of VM manageability. Definitely not the kind of support tickets you want on a Friday afternoon. Stick to PCBR.
Now, how does this apply to upgrades? Specifically, the microservices infrastructure upgrade. This is a very testable edge case. You can't just click Upgrade in the UI and walk away to grab a coffee if PCBR is running. It's a strict manual flow. Step 1. Manually disable PCBR. Step 2. Perform the microservices upgrade. Step 3. You have to actively verify that the PC cluster is stable. You do this by running the cluster status command via the command line and running your Nutanix cluster check, or NCC, health checks. Actually take the time to verify those outputs. Only when everything comes back 100% healthy do you move to Step 4 and re-enable PCBR. Knowing this exact manual flow is a prime target for the test.
Section 5. Key facts to memorize. Let's wrap up with a rapid-fire review of the non-negotiable facts you just have to know.
Lock these numbers in right now. For PCBR continuous backup, your guaranteed recovery point objective, or RPO, is exactly 30 minutes. The time it takes to get it back up, the RTO, is 90 minutes. And for a 3-node scale-out HA deployment, it can survive the loss of exactly 1 PCVM. If a scenario asks what happens when 2 nodes fail, the answer is always that the service goes inactive. 30, 90, 1. Commit them to memory.
So as you finish preparing for the exam and get back to your day job, I'm going to leave you with this. Are you absolutely 100% certain your PCVMs are excluded from your standard third-party VM backups right now? Go verify those backup policies today. Make sure your multi-cluster management plane is truly protected by PCBR so you avoid those fatal state inconsistencies. You now have the practical knowledge to not only crush these questions on test day, but to actually keep your data center fully resilient. Thanks for hanging out with me for this explainer, and good luck on your certification.